my name is Sedula. My roll number is 447. Today I am here to present the ISC activity. The topic is merchant circle diagram, derivation and numerical problem. So first, what is machining? Machining is a material removal process in which a cutting tool removes a unwanted material from a workpiece in the form of chips. So during machining, various forces act on the workpiece and the tool. So for understanding these forces is essential because it improves the machining efficiency. It improves the material removal rate. It also affects on the surface finish and it optimizing cutting conditions. So the Ernest Merchant has developed the merchant circle diagram to analyze the graphical method to analyze the forces acting during the machining on the tool and the workpiece. So there are some assumptions that Ernest Merchant made. The first assumption is orthogonal cutting, that is 2D cutting, that is two direction cutting. The second assumption is the chip formation will be in continuous problem. The third is the shaft cutting tool will be used in machining process. Then next is there will be a constant shear angle. And the fifth assumption is no build-up edge will be formula. And the sixth is uniform material properties. So these forces act on the workpiece and the tool. The first force is a cutting force, that is acts in the direction of the cutting velocity. And the second force is thrust force, that is Ft. It acts perpendicular to the cutting force, as you see in the diagram. And the third is the resultant force, that is combination of Fc and Ft. The fourth force act is the frictional force, that is act along the rake angle. And the next is a normal force, that is perpendicular to the rake face. And the last force is the shear force. It acts along the shear plane. And normal force is normal to the shear plane. So here are the derivation of the merchant circle diagram. So first is the resultant force. It is the R is equal to under root of Fc square plus Ft square. So then we have to calculate the friction and normal forces. If we know the value of Fc and Ft, that is cutting force and thrust force, we can easily calculate the value of friction and normal forces by the formula. For the frictional force, formula is Fc sin alpha plus Ft cos alpha, and for normal force, formula is Fc cos alpha minus Ft sin alpha. Here alpha is a rake angle. So next is a frictional angle, that is calculated by tan beta is equal to F upon L. F is a frictional force and N is a normal force. And then we have to calculate shear force and normal force. We can easily calculate if we know the Fc and Ft by the formula. For a shear force, formula is Fc cos pi minus Ft sin pi. And for normal shear plane, the formula is Ft sin pi plus Ft cos pi. Here pi is the shear angle. Now we have to calculate the pi. Here is the merchant equation for calculating the pi. The equation is pi is equal to 45 degree plus alpha by 2 minus beta by 2. Here alpha is a rake angle. So next is shear stress. So for shear stress, formula is tau is equal to Fs upon As. Fs is a shear force, and for As we can calculate by the formula B2 upon sin phi. Here B is the width of cut and T1 is uncut chip thickness. So power we can calculate by the formula Fc into V. Fc is the cutting force and V is the cutting velocity. Then we will calculate the one numerical based on the following derivations. So here are the given data. First is the Fc, that is cutting force, that is 1000 Newton, and thrust force is given as 600 Newton, and the rake angle, that is alpha, is given as 10 degree, and the width of cut, that is B is equal to 3 mm, the uncut chip thickness is given as 0.5 mm. So first we will calculate the resultant force by the simple formula under root Fc square plus Ft square. So value of R will be 1166.19 Newton. Then we will calculate the frictional and normal force. First the frictional force calculated by the formula Fc sin alpha plus Ft cos alpha. The value of F will come 674.5 Newton, and by the formula Fc cos alpha minus Ft sin alpha will calculate the normal force. The value will be 880 Newton. So next is the frictional angle, that is tan beta. So beta will become 14.6 degree, and the shear angle by the merchant shear equation, so pi will become phi will become 29.7. Next is a shear force. Shear force we can calculate by the formula Fc cos phi minus sin phi. Here is the one change, that is instead of rectangle we will get the shear plane angle. So value of shear force will come 572 Newton. So next is the shear plane area. By the formula B into T1 divided by sin pi, the shear plane area will come 3.02 mm square, and the shear stress by formula it will come 188.8 megapascal, that is Newton per mm square. Next is by following analysis of result will come. First is the effect on pull wear. So if we consider if we get the higher friction angle, then we will get the higher pull wear, and if we get the high cutting force, then we will get the increase in temperature. Next is the effect on efficiency. Lower friction angle improves the cutting efficiency, and optimal drag angle reduces cutting force. Now, for optimizing the result, we can increase the drag angle to reduce cutting force, and if we use cutting fluid to reduce friction, then select the proper cutting speed. And the fourth optimization we can do is use coated tools to reduce the wear and optimize fit rate and depth of cut. So, merchant circle diagram usually in every industry for machining like turning, milling, shaping, drilling, or grooving. So, to predict forces and improve productivity in manufacturing industry. The conclusion is the merchant circle diagram provides a systematic method to analyze the different forces acting on the tool and workpiece. By deriving the relationship between cutting, shear, and frictional forces, engineer can optimize the machining parameters for improved tool life, surface finish, and efficiency. Thank you.